Today we're diving deep into one of the most fundamental and important topics, which is strings in Java programming. Whether you're a beginner just starting out or looking to solidify your understanding, this comprehensive tutorial will cover everything you need to know about Java strings. We'll explore string creation, manipulation, common methods, and some advanced concepts that will make you a more effective Java programmer. First, let's understand what strings actually are in Java. Conceptually, Java strings are sequences of Unicode characters. For example, if I create a string like this string consists of 5 Unicode characters, J, V, and the trademark symbol TM. Notice how I can even include special Unicode characters using escape sequences like \U2122 for the trademark symbol. Now here's something important to understand. Java doesn't have a built-in string type like some other languages. Instead, the standard Java library contains a predefined class called string. Every time you create a quoted string, you're actually creating an instance of the string class. Let me show you some basic string declarations. This class-based approach gives us incredible power and flexibility when working with text data, as we'll see throughout this tutorial. One of the most common operations you'll perform with strings is extracting substrings. Java makes this easy with the substring method. Let me demonstrate. This creates a new string containing hell. But wait, why does substring 03 give us hell and not hell? Here's the key: the second parameter is the first position you don't want to copy. So when I say substring 03, I'm telling Java start at position 0 inclusive, stop at position 3 exclusive, give me positions 0, 1, and 2. This might seem confusing at first, but there's actually a brilliant advantage to this approach. Computing the length of any substring becomes trivially easy. The string substring of a comma b always has length b minus a. So our substring hell has length 3 minus 0 equals 3. Pretty neat, right? You can also use substring with just one parameter to get everything from that position to the end. Now let's talk about joining strings together, which we call concatenation. Java makes this super simple with the plus operator. This sets message to expletive deleted. Notice there's no space between the words. The plus operator joins strings exactly as they are given. But here's where it gets really interesting. When you concatenate a string with a non-string value, Java automatically converts the other value to a string. This feature is incredibly useful in output statements. For more complex joining operations, Java provides some powerful methods. If you need to join multiple strings with a delimiter, use the static join method. And since Java 11, there's even a repeat method. These methods can save you a lot of manual string manipulation. Now we come to one of the most important concepts about Java strings. They are immutable. This means once a string is created, you cannot change its contents. Let me show you what I mean. If I have string greeting equals hello and I want to change it to help, I can't just modify the existing string. There's no method that lets you change individual characters. Instead, I have to create a new string. This doesn't modify the original hello string. It creates a completely new string help and makes the greeting variable point to it. Now you might be thinking, isn't this inefficient? And you'd be partially right. Creating new strings for every modification does seem wasteful. But immutable strings have a huge advantage. They can be shared safely. Think of strings as sitting in a common pool. When you copy a string variable, both variables can safely point to the same string in memory because nobody can modify it. This sharing saves tremendous amounts of memory in real applications. The Java designers decided that the efficiency gains from sharing outweigh the costs of creating new strings for modifications. And when you think about it, most of the time you're comparing strings rather than modifying them anyway. Testing whether two strings are equal is something you'll do constantly, but there's a critical mistake that many beginners make. The correct way to test string equality is with the equals method. You can use this with string variables or string literals. Or case-insensitive comparison, use equals ignore case. But here's the critical mistake: never use the equals equals operator to compare strings. Let me show you why. The equals equals operator only checks if two string variables point to the exact same object in memory. It doesn't compare the actual content. String literals might be shared, but strings created through operations like concatenation or substring are not guaranteed to be shared. This can lead to bugs that appear randomly and are incredibly difficult to track down. So remember, always use equals for string comparison. Let's talk about two special cases you'll encounter: empty strings and null strings. An empty string is a string with 0 characters. You can test for empty strings in two ways. But there's another possibility: a string variable can hold null, which means no object is associated with the variable at all. Here's something crucial: if you try to call methods on a null string, you'll get a null pointer exception. So when you need to check that a string is neither null nor empty, always test for null first. The order matters. If str is null and you check str.length of first, your program will crash. The string class contains over 50 methods. Let me show you the most important ones you'll use regularly. Here's a scenario you'll face often: building up a long string from many smaller pieces, like reading words from a file or processing user input. Using string concatenation seems natural, but this is incredibly inefficient. Remember, strings are immutable, so each concatenation creates a brand new string object. For 1,000 iterations, you're creating 1,000 string objects and throwing away 999 of them. The solution is StringBuilder. StringBuilder uses an internal buffer that can grow as needed. You're only creating one final string at the end. For any operation involving multiple string modifications, StringBuilder is your best friend. With over 50 methods in the string class, you can't memorize everything. That's why learning to use the official Java API documentation is crucial. You can find it at the link shared here. The documentation shows you method signatures, parameter descriptions, return values, usage examples, version information. And that's your complete guide to Java strings. We've covered string basics and Unicode support, substring extraction and concatenation, the critical concept of immutability, proper equality testing, handling empty and null strings, essential string methods, efficient string building with StringBuilder, how to use the API documentation.